Hi everyone, today I'm working through the Hornsby Boys 2021 Extension 2 Trial Exam question 16 Part E, which says that the positive integers are grouped as follows. So we've got 1, and then in the next group we've got 2 and 3, and then in the next group we've got 4 and 5 and 6, and then we've got 7, 8, 9 and 10, and so on. And we're told that the nth group will have n integers. And the question is to prove that the sum of the integers in the nth group will be n on 2 times n squared plus 1. So, in terms of thinking of this, I think if I just note out what our groups of integers are. So, we're taking all the positive integers and breaking them up into little subgroups. The first group is just the number 1 by itself. The second group is 2 and then 3. Third group is 4, 5, and 6. And then the fourth group is 7, 8, 9, and 10. And that pattern continues, noticing that for each group, the number of terms in that group is equal to the number of the group. So group 1 has 1 term, group 2 has 2 terms, group 3 has 3 terms, and so on. And so it makes sense that we're expressly told that the nth group naturally will have n terms. And I think the first thing to notice is that all of these groups are, we can say that each group is an arithmetic progression. And whilst they each have a different starting term, a different a in terms of how we normally refer to arithmetic progressions, they all have the same difference because they're all going up by just 1. So each group is an AP with D is equal to 1, and the number of terms being whatever number group it is. So I think that's useful because we can therefore say, that the sum of the nth group, which is what this question is all about, will be equal to, and we can use our sum of a GP formula. So it'll be the number of terms divided by 2, and we know there's n terms in the nth group, times 2a plus n minus 1d. That's the general formula for the sum of an arithmetic progression, where a is the first term and d is the difference. We've noticed that the difference for all of these groups, which will also include the nth group, is just 1. So we can simplify this a little bit. We can say it will be n on 2 times 2a plus just n minus 1, since anything times 1 is just what we've got. So that's kind of what we're working towards, and really the focus now becomes on what is a, because if we can work out a expression for a and substitute it in, hopefully it then simplifies to what the question has asked us to prove. So now what we really need to think about is the first term in each of these groups and what pattern that follows. So notice that if I hone in on the first term in each group, what I've just circled, if I flesh that out, we've really got just 1, which, 1 is equal to 1. And then we've got 2, which is equal to 1 plus 1. And then we've got 4, which is equal to 1 plus 1 plus 2. And then we've got 7, which is equal to 1 plus 1 plus 2 plus 3. And hopefully just with these early groups, you can see the pattern emerging, because we always have a 1, and then we add something where the final thing that we add is also growing by 1. So we'll have just our 1, and then in the next group we'll take that 1 and we'll add 1. And then in the next group, we'll take that 1 plus 1, and then we'll add 2. And then in the next group, we'll take that 1 plus 1 plus 2 and add 3. And so the pattern that's emerging to give us our first term is essentially take whatever you had for the first term in the prior group, and then add a number that is equal to whatever that final number in the prior group was plus 1. So yeah, I think we can now extend that, because what we can say is that if we kind of were to follow that pattern, the first term in the nth group would be equal to, the nth group would be equal to, well, we'll just have our 1 plus 1 plus 2 plus 3 and so on. And we'd keep going up until, well, in the first group, we kind of, added really 1 plus 0. In the second group, we added just 1, which is 2 minus 1. In the third group, we ended up with 2, which is 3 minus 1. In the fourth group, we stopped at 3, which is 4 minus 1. So really, in the nth group, you're going to keep going and you're going to stop at n minus 1. Whatever group number it is, you stop at the number just prior to that. So we take everything we would have added up before and we stop at n minus 1. And I think if you kind of just note that everything starts with a 1 and you hone in on just what comes after that first 1, so 1 plus a whole bunch of stuff, this whole bunch of stuff that we're adding is itself an arithmetic progression with its first term, or a, as 1, and the difference is also 1, and we have n minus 1 terms. So actually, the first term in the nth group will be equal to 1 plus the sum of this arithmetic progression. So we can now make use of our generic arithmetic progression formula, substituting these values. That gives us the a of this first arithmetic progression, and then hopefully we can get everything to simplify. So you can see how this is kind of a tricky question because it's kind of 2 layers of arithmetic progressions that we're dealing with. But actually, once you've got your head around that, it really is just making use of this fairly simple formula that hopefully you're quite familiar with from just advanced maths, really. So what I'll do is I'll turn over and then we'll say, therefore, the first term in the nth group will be equal to 1 plus, because we can't forget our first 1 here, plus, and now it'll be, well, it's n on 2 times 2a plus n minus 1d, but wherever we see n, we need to put n minus 1, because we've got n minus 1 terms. And then wherever we see a, we can just put 1, and wherever we see d, we can put 1. So really what that will be is it will be n minus 1 on 2 times 2a, or 2 times 1, plus n minus 1 minus 1 times d, or times 1. So if we think about what that simplifies to, we'll have 1 plus n minus 1 on 2 times 2 plus n minus 1 minus 1, which is 1 plus n minus 1 on 2 times 2 plus n minus 2. So these are 2 minus 2, they kind of cancel each other out. So we end up with 1 plus, and it's just n times n minus 1 on 2. Alright, so now if we think of how this can simplify, I'll just get a common denominator of 2. So that would be 2 plus n minus 1, all divided by 2. And then if I expand out this bracket, we get 2 plus n squared minus n divided by 2. And if I just kind of write this kind of with the n's first, we can just say that's n squared minus n plus 2 all divided by 2. So this is the a that we needed to work out to then substitute back in. So now we need to substitute that back in as a to then get the sum of the nth group, which is what this question wanted us to focus on. So if we come back to the next page, we can say, therefore, the sum of the nth group is equal to n on 2 times a, which is what we've just worked out here, which is n squared minus n plus 2 on 2. And if I just double check, plus n minus 1. So plus n minus 1. Now in terms of simplifying this 2 and this 2 will cancel, so it's n on 2, and then we have n squared minus n plus 2 plus n minus 1. And the minus n and plus n will cancel, and the 2 minus 1 will just become 1. So that is n on 2 times n squared plus 1. And that is as required. That is exactly what the question asked us to prove. So yeah, there you have it. That's how you go about that question. It's just 2 iterations of the sum of an arithmetic progression. I think the tricky part of this question, what kind of warrants it cropping up as a final question on an Extension 2 trial exam, is, I guess, first of all, your ability to spot patterns. What's really going on here? Do you notice the pattern? And there's, first of all, the pattern that each group itself is an arithmetic progression, but then also the pattern that the first term in each group is comprised of 1 plus an arithmetic progression. I guess maybe not everyone would notice that, but I think once you do notice that, the actual mechanics of the formulas involved are fairly straightforward. You still need to be careful though, because you kind of could get mixed up with all the A's and D's flying around. And even the n's, because you know, you've got n and then you've got n minus 1, and I could see a lot of students under the pressure of an exam making mistakes there. But I think as long as you're careful, you will get to ultimately what's being asked to be proved. So yeah, hopefully you found that explanation helpful, and tick boom.